Welcome back to the deep dive. Today, we're jumping into another fascinating sequence from the OEIS. It's A000344. Now, this one's sometimes tagged as easy, but, well, if you're studying number theory, you'll quickly see there's a lot more going on under the hood, really deep connections.
That's right. It looks simple enough at first glance. The defining formula is 1 to n, n2, n2, n plus 3. Note that it kicks off at n equals 2.
Okay, so 5 times a binomial coefficient divided by n plus 3. What are the first few numbers it spits out? Give us a feel for its growth.
Sure. So starting at n2, the sequence goes 1, then 5, 20, 75, 275, 1001, 3640. They definitely pick up speed pretty quickly.
They certainly do. So, okay, N2 is the start. What are these numbers? I mean, what are they actually counting? Is there a combinatorial picture?
Yes, absolutely. And the most accessible way to think about it is using lattice paths. Imagine you're on a grid starting at 0, 0. You want to get to n, just taking steps east, so 1, 0, or north, 0, 1. 0, 0, 0, 0, 3, 4, 4 counts the paths that do this, but, and this is the important part, they have to touch the line 6y, $2, but they're not allowed to cross it. So 6y can equal 2, but never 3 or more.
Ah, okay. So not like the standard Catalan numbers where the boundary is 6y or 6y to logos. This boundary is shifted out by 2.
Exactly. That shift makes all the difference.
Can we make that concrete? Maybe with an example.
Sure. Let's take n3. The sequence value over 3 is 5. And those 5 paths are, let me see, enan, 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 and enan. If you trace those out, you'll see they all hit a point where x is exactly 2 more than y, but they never go beyond that difference.
Right. Visualizing those paths, hitting that 6y, 2, 2 line, but staying below or on it really helps.
Right.
Okay. You mentioned other interpretations briefly in the sources.
Well, yes, there's another significant one. AN also counts the number of standard Young tableaux that have the specific shape, n plus 2, n2. So this pulls it into, representation theory and algebraic combinatorics. It's not just about paths.
Okay, fascinating. Now, you hinted at it, and this feels like the core connection. The link to the Catalan numbers A000108. How does A000344 relate?
Yes. This is where the structure really shines. There are a few ways to see it. Probably the most fundamental is through their generating functions. Let C be the generating function for the Catalan numbers. The generating function for this sequence, A000344, is basically 6 pi dollars times C to the 5, the 5th power of the Catalan generating function.
The 5th power. Just from shifting that boundary line 2 steps. Why 5? That seems dramatic.
It does, but it makes sense combinatorially. That condition, touching but not crossing 6y22, it effectively imposes constraints that correspond to 5 independent Catalan-like structures interacting. So another way to put it is that AN is the 5th convolution of the Catalan numbers.
Wow, okay. So AN is like a sum of products of 5 Catalan numbers, GZI, CJ, CK, where the indices sum up correctly.
Precisely. The sum is over 1 plus J plus K plus L plus M plus N22, involving 5 terms CAC, CKS. There's also a direct linear relationship. AN is 2M plus 2, 3CM plus 1 plus CN, where CK is the kth Catalan number A000010K.
Amazing how interconnected these sequences are. And for computation, the sources mention it's d-finite. What does that mean practically for, say, a student calculating terms?
Right, d-finite. It basically means it satisfies a nice linear recurrence relation with polynomial coefficients. This is often much simpler than using the main binomial formula, especially for larger n. The relation is 1n plus 3, n s 2an, equals 2n, 2n, 1, s initial 1. Quite neat, actually.
Yeah, much cleaner for programming.
Yeah.
Okay, last thing. How fast does it grow? We saw the initial terms, but what's the long-term trend?
It grows exponentially, as you'd expect from the Catalan connection. The asymptotic formula is approximately an simpraf times 4. You see that $4, the hallmark of Catalan-related growth, scaled by 5 and then slightly damped by the NSUP of the denominator.
So wrapping this up, the key takeaway for you listening is how this sequence, A000044, really bridges a simple-sounding geometric constraint, those lattice paths, just touching 6y2 with some pretty sophisticated algebraic structure involving the 5th power of the Catalan function.
Exactly. And it leaves us with a thought, doesn't it? We shifted the boundary by 2 and got C$5. So a question for you to ponder. What happens if you shift the boundary further? What if you counted paths touching but not crossing 6y dollars? What power of the Catalan generating function might you expect to see then? Something to explore.